In today's rapidly changing world, resource depletion and environmental pollution pose severe risks to our society's survival. The economic costs associated with the paramount energy consumption and the consequences of greenhouse gas emissions and exacerbating climate change call for prompt, decisive action. By reinventing the way we produce and consume energy and resources, industrial symbiosis offers a promising pathway towards a more sustainable, resilient future. It transforms resources, energy, and byproducts of one industry into valuable resources for others through innovative cross-sector collaborations and partnerships, optimizing resource utilization and leading to lower costs. CORALIS is a 4-year EU-funded project whose aim is to pave the way for the decarbonization of resource and energy-intensive sector value chains by generating real experience on the deployment of industrial symbiosis solutions while focusing on 3 crucial factors: technological, managerial, and economical. CORALIS approach is being demonstrated in a total of 3 industrial parks of the European industry, covering a wide range of sectors and geographical dimensions, while 3 additional industrial parks will follow project results and replicate them after the project's end.
And what we've done in CORALIS and here in Frövi is to create a tomato greenhouse using waste heat from the carton factory at Basauri. Our job in CORALIS is to create a lighthouse project to show the way to others of how to create industrial symbiosis. So the question is, how do we do that? Fundamental for how we do that is we make creating industrial symbiosis our business. The tool we have to that is a business model which brings together the anchor industry, financial actors, property company that we create, and the grower of, in this case, tomatoes. And within that business model, we can address the economic issues for all the actors, the sustainability goals which all these actors share and have their own, but also bring together all the legal agreements and, perhaps most fundamentally, co-create the technological systems to get all the flows working together. So in all, you can say that this business model helps us manage the complexity which industrial symbiosis creates, because instead of just having one actor making an investment, you have in this case 4 different actors, each adding their layer of complexity. And the results are now here to see. So at Frövi you can now see a tomato greenhouse. Perhaps most importantly, almost every supermarket in Sweden you can buy and taste the results of industrial symbiosis.
The Italian lighthouse of Brescia is focused on metallurgy sector of aluminium, cast iron and steel. Main target of the symbiosis activity is the recovery of material from waste or byproducts in order to replace raw materials as input of another or even the same industrial process. In Brescia Lighthouse there are 1 lighthouse coordinator, RINA, 1 local facilitator, Confindustria Brescia, the University of Brescia and 4 industrial companies that are the core of the industrial symbiosis scheme. The cast iron foundry Fonderia di Torbole is testing a separation unit for processing sandblasting powder of internal mechanical processing. 2 separate flows of iron powder and silica generate from this. Moreover, the company aims to add biochar inside the cupola furnace, replacing some of the fossil coke that is generally used as a reducing agent. Steelmaking company Henri Martin is working to recover internal production of metal oxides and iron powder from Fonderia di Torbole, realizing briquettes with fossil coal and eventually biochar as a reducing agent. Then briquettes are sent to Henri Martin electric arc furnace. Rough metal is a secondary aluminium producer. Input of rough metal process is aluminium scrap that is pre-treated before melting in special furnaces. Pretreatment stage produces waste with still a certain content of aluminium and other metals. Rough Metal is working to realize a pyrolysis unit for treatment of this waste in order to recover aluminium for internal reuse, inert material and other metals such as iron and steel to be sent to other CORALIS partners. Feralpi steelmaking companies is performing tests for a reducing furnace. Input of these plants are metal oxide from Feralpi itself and Orimarten, silica from Fonderia di Torbole and inert material from Rough Metal. From this complex network among companies, undesired waste, or byproducts, becomes alternative resources, reducing carbon dioxide emissions and promoting the development of a circular economy and further symbiotic interactions.
Grupo Fertiberia, a fertilizers company, participates in the CORALIS project together with Química del Estroncio plant located in the Escombreras cluster in the southeast coast of Spain, Murcia region. The aim of the Escombreras demo site is to readapt the production process in Química del Estroncio, which produces several types of nitrate, carbonate and sulfates, to replace imported raw materials such as hydrochloric acid and calcium carbonate, utilize CO2 and sulfuric acid, which are byproducts from surrounding industries, and to reduce wastewater discharge and water consumption. What is more, the demo site also aims to showcase the reduction of CO2 emissions at park level, as well as conduct a technical economical study for the installation of a CSP plant to decarbonize the energy supply of the industrial area. The project is pivoted around a new plant concept of potassium nitrate production, patented by Fertiberia, that substitutes the former one, which was less efficient in material and energy consumption and also significantly reduced its water needs. In addition to the demonstration plant, it has been necessary to design and install 3 pilot plants to obtain a byproduct, hydrochloric acid, reusable within the facility, and the recovery of waste for this transformation into raw materials in a perfect circular economy. Also, the pilot plants demonstrate the reuse of byproducts from neighboring companies in the industrial park in a symbiotic way. During the project development, some important results have been demonstrated to be shared within the sector and with the industry in general for industrial symbiosis, such as the use of glycerol, CO2, hydrochloric acid and sulfuric acid, low-value byproduct from some industry that can be upgraded as raw materials for others.
Within CORALIS, besides the demo cases where real industrial symbiosis is implemented, we are also supporting 3 industrial clusters in Europe for their future implementation of industrial symbiosis. These so-called follower cases are located in Spain, in Austria and in Turkey. In Spain, we are looking at waste heat recovery from a steel shop. In Austria, we are looking for renewable hydrogen applications, and in Turkey we are going to have an approach on the circular economy for materials that are spent in a refinery. So all of that is technically evaluated within the project, but we also provide real support in terms of how to engage with the relevant stakeholders, how to communicate and how to develop a vision that these industrial symbiosis cases really can come into life in the future and be implemented on a higher maturity level and to be seen as real options also for other industrial clusters all over Europe that have similar problems, that have similar situations, and that can learn from those learnings that we have within CORALIS.
Each of the 6 industrial initiatives of the CORALIS project has succeeded in its course. CORALIS has shown that existing methodologies can be applied to industrial symbiosis solutions, with the need of minor modifications for each specific case. CORALIS partners are now more aware about the implications of industrial symbiosis and are ready to take new initiatives on this field. Moving forward, we think we should continue with the validation of new industrial symbiosis solutions, validating them, and at the same time, we should continue improving the administration processes for the use of waste resources. So far, environmental and regulatory aspects have taken a back seat to economic factors, but CORALIS has shown that if we provide them equal opportunities, industrial symbiosis can be another way to decarbonize industrial processes.